All right, this is number 3 from the worksheet from yesterday, where we had to determine if it was even, odd, or neither, and show the reasoning. So first of all, we look at number 3, and the graph is doing this. It's an exponential function. So would you say that that is even, odd, or neither?
Neither.
It's neither.
It's got to be neither.
Exactly. You cannot cut it in half with the y-axis as a line of symmetry, and you cannot rotate it 180 degrees and it land back on itself. So therefore, it is definitely neither. Now we still have to show y. So we're going to plug in negative x. So f of negative x equals 2 to the negative x. Now, when I simplify this, if I end up with exactly what I started with, and I originally started with f of x equals 2 to the x. If I end up with this, then I know it's even. If it's exactly opposite, I know it's odd. If it's neither of those, it's neither. And that's what's going to happen. Because when I have a negative exponent, it tells me to take the reciprocal and to change the sign of the exponent. So 1 over 2 to the x is what we end up with, which is not the same and it's not opposite. It is neither. Okay, that's number 3. Let's look at number 4. Okay, number 4, the original function was 1 over x to the 4th plus 1. The graph looks like this. Okay, so on first glance, you would think it was even because the y-axis cuts this graph in half such that it has mirror images. So we would think that it's even. Now we have to prove it. So we're going to plug in negative x. You always plug in negative x to test it. So everywhere there's an x, we're going to plug in a negative x. Make sure you put parentheses around that negative x. All right, now, if I ever take a negative number to an even exponent, it's positive, right?
Yes.
So this is really just x to the 4th, just like it was at the beginning. So has anything changed from the original? No. So we know that this is definitely even. All right, let's look at number 5. Okay, in number 5, our function is f of x. F of x equals x minus 1 over x plus 1. The graph is what we call a rational function that looks like this. Now, it's a rational function, but can we rotate this around the origin and it land on itself? No. So it's not even, clearly not even, and it's not odd either because this graph has been shifted. If it was the way the parent rational function is, then it would be odd because you could rotate it 180 degrees and it would land on itself. But since this thing is shifted, the center point, if you will, the rotation point is now up here instead of being the origin. So this is not going to be odd. So it's neither. But now we have to prove it. So we plug in negative x. Everywhere there's an x. Okay, so when we plug in negative x and we simplify, this is negative x minus 1. This is negative x plus 1. So if it's exactly the same as the original, we know that it's even, but it's not. If it's exactly the opposite of the original, then it's odd, but it's not. Why? Because the negative 1 and the positive 1 stay the same. So it's partially opposite and partially the same. If that ever happens, a little bit of both, it's got to be neither. Okay? You already knew it was going to be neither. But this confirms that it's neither.
You're going to have one where it's going to be neither, but it ain't going to confirm.
No, it'll always match up. All right, number 6. Last one. All right, f of x equals x over x plus 2. The graph, again, is a shifted rational function. So when we shift a rational function, it's going to be neither. But this would also be neither. When we confirm it by plugging in negative x, you get negative x over negative x plus 2. So that's just negative x over negative x plus 2. So we have opposite x values, but we've got the same constant value. And if it's not all opposite or all the same, it's got to be neither. And that's what it is. All right, so how do we test even, odd, or neither? We plug in negative x everywhere there's an x. For an even function, it's going to come out the exact same as it started. Exactly the same as it started with the original f of x. If it's odd, it's going to come out exactly opposite of what we started with. All the signs will be the opposite. And if it's neither, it's probably going to have a little bit of both situations. A little bit of the same and a little bit of the opposite. But if you combine those, it's going to be neither. From the graph, we know that it's even if the y-axis serves as a line of symmetry. In other words, it will cut that figure, that graph, into equal parts that can be folded onto one another perfectly. An odd function is a function that you can rotate about the origin. In other words, put your finger on the origin, rotate your paper 180 degrees, and it would land back on itself or look exactly the way it looks when you started. That's odd. If you do not have a line of symmetry that is the y-axis, and if you cannot rotate it 180 degrees about the origin, then it's neither. So we should be able to know how to identify these functions, odd or even, from looking at the graph or from looking at or working with the function equation.